Hello and welcome everyone. I hope you all are doing well. Before starting this session, let me introduce myself first. My name is Laxmi. I am currently working as an assistant professor at Kite Deemed to be University, and I have been teaching Java from last 1 year. So today's topic is object-oriented programming in Java. As we all know, this is the most important topic in all the programming languages, which we will be covering with the reference of the Java language, right? First, let's talk about what is OOP. OOP models the software after real-world objects. Like in real world, we have objects and classes. What is class is? Class is a blueprint defining structure and behavior only, right? And if we talk about the object, object is a real world entity. For example, if we have employee class, so employee is not the existing or a real world entity. But if we talk about Alice, which is a employee, right? So this is the Alice is a object which defines the class which is employee, right? Next, let's talk about the four pillars of the OOPS. We have four pillars. Uh, First is encapsulation, second, inheritance, third, polymorphism, and fourth is abstraction. If we talk about the encapsulation, we can treat it as a bundle of data and methods and which hides the internal functionality and expose only what's the needed. Like if we take about an example of capsule, so the medicine inside the capsule is safe and we can interact with the medicine but not directly, but with a defined mechanism. So in programming language, first pillar is uh, encapsulation. Next is inheritance. Inheritance means extending the behavior of the parent class to the child onwards, right? Like child classes reuse and extend parent behavior, no code duplication. There will be no code duplication, but the behavior and the properties of the parent class a child can use, right? Third one is polymorphism. As the name says it all, polymorphism is using something in many forms, like one interface, many forms, same method called different behavior. Next is abstraction. Then abstraction focus what it does, not how. Like if we can take an example of car only. So in the car, we have limited objects that are visible to us, and for a driver, it's important to know that how the car is not the how the car is working, but it's the what model of the car is work, right? So means it is basically used for hiding the complexity and for the simple interfaces. For example, driver will be only knowing that how to use the steering in the car, but he will not be knowing that how steering is internally working, right? So that process is called as abstraction. In programming language, we have different of functionalities in the front end, but in the back end, a client doesn't need to know that what is happening in the back end, but he all he need to know is how to use that front end, right? So let's talk about first pillar. Encapsulation keeps an object's data private and expose it only through a public method. The method calls are getters and setter. Like if I have taken the example previously of medicine, of capsule, right? So medicine is encapsulated or wrapped in a capsule form, right? So in our programming language, also object data will be private, and we will be accessing it not directly, but with the help of the getter and setter method, right? So this protects the data integrity and reduces unintended side effects. If we take another real world example, when we gift something to our friend and family members, we used to wrap it in a cover, right? So why we used to do it? Have you think about it? No. So we use it to maintain the integrity so that we can ensure that the gift can be opened by the desired person only, right? And gift can be opened not directly but via that after removing the wrapper, right? So in encapsulation, we mark field as private and provide public getters and setter method, and we only validate data before storing it, right? Like in the code, I have taken an example of employee, and we have two attributes, name and salary, which both are private. As these are private, so we cannot access them in some another class without having the appropriate public methods. So we use public get name and get salary method to access them from another class outside this employee class, right? And through the getter and setter method, through the getter and get salary and get name method, we will be accessing the name and the salary of the employee in another class. So this is the example and a brief about the encapsulation. Let's talk about the pillar second, which is inheritance. Inheritance means extended the properties and the behavior of the parent class into the child class, right? So it basically ensured the reusability of the code. Like if we have common functionalities and we have to perform some common task, so we can define a method performing that task in the parent class, right? And in the child class we do not need to implement the method from the scratch, but rather than we can extend those method coming from the parent class into the child class. So it ensures the reusability what already works or what already exists, right? So a child class inherit all fields and method of its parent using extend keyword. Extend keyword is a reserve keyword which will be using for the inheritance, right? And the class from which we are inheriting some methods or behavior will be called as the parent class, and the class which is inheriting the methods and the behavior is called as a child class. Okay, so extend keyword will create the relationship. Super method or constructor will be used to calling the method or constructor of the parent class. And at the rate override annotation will be replaces on the parent behavior, which will be indication that this class is overriding using the overrided method, right? If we have example, first we have manager class. This is the manager class which is extended the employee class. Manager itself an employee, as we all know. So we have previously defined the employee class that will be having name and salary. But we have some another class which is manager, right? So which has same attribute as name and salary. So rather than defining them from scratch and again, we will be using those attributes from the employee class only, right? So we have another method, another attribute, team size, which is also private in the manager class. And via this constructor, public manager will be accessing and using the name, salary, and team size. Name and salary are coming from the employee only. We are not defining separately in the manager class, right? And with the help of the super constructor, we are calling name and salary, which is referring that the name and salary will be coming from the employee class, right? And we have a method int get team size, so we'll be returning the team size. So this is a brief about the inheritance only, right? Next we'll talk about the polymorphism. As I mentioned before, polymorphism is using some method in the many forms, right? So we have two types of polymorphism. One is compile time polymorphism and second is runtime polymorphism. In compile time polymorphism, we also called it as method overloading. Multiple methods share the same name but different in parameter types or count, right? Number of parameter can be a different and type of a parameter can be a different. We'll be learning it via example after. So the compiler decides which to call at compile time. Means when we compile our code, so compiler decide which method or constructor will be calling uh, with the appropriate syntax. So as compiler defined it's on compile time. So this polymorphism is also called as compile time polymorphism, right? And suppose we have a class, employee class, which is having string name and a constructor which is non-argument constructor, okay, which is defining the name attribute. Then we are overloading it by the same name of the constructor which is employee, and but the parameter we are giving it to the name, which data type is string type of data, right? So these are two constructors with the same name but different parameters and different type of parameter. Count is also different, and type of the attribute is also different. Now we have third one, another constructor with the same name but two attributes. One is name and the salary. So the type and the count of the parameter is also different here, right? So we have three constructor to overload or to implement the compile time polymorphism, right? We have a method which is print info, right? Print info, what the method is doing, it is simply printing the name of the employee, right? And we have another method also which will be printing the name of the employee with a specific condition, like with if detail about the employee is condition is true, then it will be printing the employee name, otherwise it is printing the name, right? So we have, what we have done here is method overloading, right? Next we'll talk about the runtime polymorphism. At the compile time polymorphism, compiler decides at the compile time let which method will be called, but as it is runtime polymorphism, then we'll be that at deciding at runtime that which method will be called, right? So a child class redefined a parent method for runtime inheritance, for runtime polymorphism, inheritance should be there in the code, right? So when parent class method will be overriding by the child class method, the method will be same, but the implementation or working in the child class can be different. So this process is called the method overload overriding, right? Java decide which version to run at execution time based on the actual object type, right? So this is called the runtime polymorphism. As we can see in the code, we have employee class, right? Which have one method which is get salary, right? And the manager class which is extended the employee class and implementing the same method, right? Which is get salary, but it is returning 80,000 as manager earns more, but the method is same but returning the different type of salary according to the employee, right? And if there is a simple employee, then it will be returning a 50,000, right? And also here we are using the annotation at the rate override, which is indicating the method get salary is overridden from the employee class. So the parent class will be the employee class and the manager class will be called as child class, right? And when we call when we call both the method, if we call the employee method, then simply we'll be creating the employee class object and calling the even dot get salary here. So it will be printing 50,000. But if we want to call this method overridden method, then we have to refer the employee class by creating the manager class object. Yani parent will be referring and object will be creating of the child class, right? So e2 get salary will be printing the 80,000. So I hope runtime polymorphism is also clear. Next, we have pillar 4, which is abstraction. Abstraction means hiding the complexity and showing the essentials. Essentials mean only showing the required informations or required functioning to the client or to the user, right? The behind what implementation behind the scene is can be more complex. So basically, making the interface very user friendly, we use abstraction as well, right? Abstraction defines what a class must do without specifying who, right? We will be defining to the driver like what a steering do, what a gearbox is working, how rather than defining how it's working internally, right? Driver should know what is the use of the engine of the car rather than be knowing that how engine is implemented internally, right? So to remove the complexity for the user, we used to implement the concept abstraction only, right? Where we can implement it via two methods. First one is by creating the abstract class, which is partial implementation of the abstraction, and another one is interface, which is pure contract the abstraction method. This is 100% abstraction, right? And also we have to remember one thing as well. We cannot instantiate abstract classes directly. Like to create the object of the abstract class, we have to refer the and creating the object of the child class, because in the abstract class there are some method present which are abstract and having no implementation, right? So we cannot directly create object of the abstract class. For example, we have a class which is employee and we have declared it as an abstract class, right? So we have a method which is concrete method, which is not abstract method. Okay. So the method is printing that who is in the meeting, right? Another we have calculate bonus method, which is abstract. Why we made it as abstract method? Because for the employee, how much bonus is company giving to them is only matters, right? How the bonus is calculating, it is the backend process, right? So we will not be showing any employee that how the bonus is calculating, how the calculations are done, right? So we have made this method as abstract. Okay. Next, we have developer class extend which extends employee. So public double calculate bonus. There are a calculate bonus method which is returning a fixed amount of bonus, that is 5,000, right? Another class we have is salesperson, which is also extending the employee class, right? So public double calculate bonus will be returning the 10,000 for a salesperson. So for a developer, we are giving a fixed amount of bonus 5,000, and salesperson we are giving a fixed amount of bonus which is 10,000, right? So next, putting all together, first one, if we talk about the encapsulation is basically wrapping up the data so that we can maintain the integrity and no one can directly access to the data, right? After that, in the inheritance we use to increase the reusability of the code so that the code cannot become very large, and we do not need to implement the similar behavior or similar approach again and again for every individual class, right? So next, what are the key takeaways from the session is, we have already taken a brief about the OOPS concept, which are encapsulation, inheritance, polymorphism. Polymorphism are also a two type of polymorphism. First is compile time, and we have already read about the why this is called as compile time polymorphism. Another is runtime polymorphism, as well as the abstraction, right? So next, it's your own responsibility to build your own employee hierarchy, like add a developer class and test polymorphism and all the OOPS